In this video, I will discuss a JEE Main PYQ from the topic Simple Harmonic Motion. Consider the spring block system. Block of mass m, spring constant K, fixed at one end. And the block is lying on a horizontal surface, frictionless surface. From this relaxed position, suppose I stretch the spring by pulling the mass here by an amount say E and then leave it. So this thing will start oscillating like this. So this motion is simple harmonic motion. So in this system, there are two forms of energy. When this mass is moving, it will have a kinetic energy half m v square, where v is the velocity of this mass. And this spring will have a potential energy stored in it half k x square, where x is the compression of the spring from the natural relaxed position. When the spring is relaxed, x is 0. When it is stretched or compressed by an amount x, the energy stored is half k x square. So the total energy is sum of these two, and this is a constant. But it moves, there will be exchange between these two terms. The velocity at this turning point is 0. So with the velocity at this left turning point is also 0. At the mean position, velocity is maximum. Once it crosses mean position, the force will be towards the mean position, so the velocity will keep on decreasing until it becomes 0 and it will turn back. Once it turns back, the velocity will keep on increasing. After that, the velocity will keep on decreasing until it becomes 0 and then turn back. And the spring potential energy U will be maximum here because the extension is maximum at this point. Here U is minimum and it is 0 because relaxed position x is 0. At this position again U is maximum. So in spring potential is maximum, kinetic energy is minimum. So the sum will be constant. So here you can see kinetic energy is maximum here, potential energy is minimum here. So the sum again will be constant. So with this basic understanding, you can solve this JEE Main question. The other question, your block of mass 2 kg is attached to one end of a massless spring whose other end is fixed at a wall. The spring mass system moves on a frictionless horizontal table. The spring's natural length is 2 meter and spring constant is 200 Newton per meter. The block is pushed in such a way that the length of the spring becomes 1 meter and then released. At a distance x meter, where x is less than 2 from the wall, the speed of the block will be. You can pause and run this question. This is based on conservation of energy. So initially the spring is in a relaxed position. And the length of the relaxed spring is 2 meters, natural length. And the spring constant K is given. So from this position, the spring is pushed towards the wall. So it comes here, so that this distance becomes 1 meter. After that it's released, so the spring will oscillate like this. On this side, it will again go to 1 meter by symmetry and then turn back and will keep oscillating. So this is simple harmonic motion. So when it's going like this, at a particular moment, it will be at a distance x from this fixed end. So at this instant, we have to find the speed v. So if you consider this as state 1, energy in the state 1 is kinetic energy at the turning point is 0. So it's half k x square. The compression is 1 because from 2 it's being compressed to 1 meter. Kinetic energy is 0. In this state 2, the energy is half k. Compression is from 2 it has become x and x is less than 2. So the compression is 2 minus x. Plus we'll have some kinetic energy. Kinetic energy will be there in this mass m. And these two are equal because energy is conserved. It's sort of frictionless stable, so there is no dissipation. So energy is same in state 1 and state 2. So if I equate these two, I can cancel half and we'll get V as V square equal to, and then I can bring this m down here and it will be 1 square, which is 1 minus 2 minus x square. So this is V square, so V is square root of this one. And K is 200, L is 10, so this is 100. So velocity will be 10 into square root of this quantity. So it is 10, then all options. So 1 minus, so it matches the option E. E is the correct answer. This is what I explained here. The relaxed state of the spring, the length is 2 meters, and from this relaxed position, this rock is being pushed so that the distance becomes 1 meter from the wall. So the amount of compression is 1 meter. After that, it's released, so it will start oscillating like this in SHM. So at a particular instant, we are at a distance of x from the wall. So at this instant, we have to find the velocity. So if we call this as initial state, the energy in this state is half k x square, where x is the compression, which is 1 meter, and this is the turning point for the extreme position. So the kinetic energy is 0. After the velocity will start picking up, and let the velocity be v in this state. So half mv square, and the kinetic energy stored in the spring in this state is half k. Compression is from 2 it has reduced to x, so it's 2 minus x whole square. These two are equal because there is no dissipation, it's on a frictionless table, so energy is conserved. So equating these two, I get the velocity as 10 into square root of this one, matches the option E.